Welcome back. So we're going to go over neural topic model, NTM. Before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So neural topic model, this is a practical guide. So NTM discovers hidden themes within large document collections without requiring labeled data. It's built on neural variational inference. It learns patterns of word co-occurrence and groups them into abstract topics that emerge naturally from your data. Unlike keyword searches for TF-IDF approaches, NTM identifies clusters of related terms even when they don't appear in the same document. For instance, words like bike, car, speed, and mileage might cluster into a transportation-related topic, though the algorithm won't label it as such. Interpreting these latent topics remains your responsibility. All right. So when do you use it? All right. NTM excels at organizing unstructured text when you lack labeled data. It's really valuable for document classification, topic-based summaries, clustering customer support logs, grouping research articles, and exploring product reviews. If you needed to make sense of large text data sets without predefined categories, this is your tool. So, understanding some of the data requirements. So, NTM can't work with raw text directly. You need to pre-process your documents first. This falls into 3 steps. 1, tokenization and vocabulary mapping. You need to convert each word into an integer index using a vocabulary file. This maps your corpus's unique words to numerical identifiers. 2, document representation. You need to transform each document into a vector of word counts. Each row in your data set represents one document as word frequency indices. 3, formatting. You need to use CSV or record.io protobuf format. The file mode works for smaller data sets, but pipe mode is preferred for large corpora as it streams directly from S3. You'll configure 3 data channels: the train channel for your document frequency data, this is required, the auxiliary channel for your vocabulary file, also required, and a validation channel for test metrics, which is optional. So we're going to go and configure the model. All right. So we're already in Amazon SageMaker AI. Training jobs, under training, click create training job. And then let's say NTM test. You get the right IAM role to access what you need to work with the AWS products. Amazon SageMaker built-in. And then you select text topic modeling, neural topic model. All right. Do the file mode when it comes to bringing it on. This is for dev. Pull it onto your computer and then process it in your pipeline from there, or pipe mode directly from your S3. That's more production ready. All right. Then you'll go for your machine learning, your instance, excuse me. So NTM is a neural network base. So GPU acceleration significantly speeds up training. So you're going to use instances like ML.P, ML.P3, P4, P5, right? And then from here, CPU instances are sufficient and cost-effective for inference and production, all right? Then you'll also remember your S3 is going to contain your training data. So you'll start by pre-processing your documents. You'll convert the raw text into the word count vectors, build a vocabulary file. So it'll have CSV mapping words to integer indices, right? And then upload both the processed documents and vocabulary file to that S3. All right. And then you'll go set up your network isolation if needed, the security groups and subnets necessary. And then you'll go to your parameters. So, okay, so your most important parameters. All right. Let's see. Num topics. All right. This goes from about 10 to 100, depending on your corpus size and desired granularity. So we'll set it at 50. Batch size or min batch size. So you want to have a good starting point, go for 512. And then let's see, your learning rate, you want to have this smooth out. So 0.01 is a solid one to go for. Then You'll select your input from that S3 we were talking about, content type. Let's see, text, CSV, compression. We won't need that if we don't zip it. The data source S3, the S3 and the paths, checkpoints if you're using the managed spot training, and your outputs, and you'll click create training job, but we're going to click cancel. So you'll launch it, you'll monitor its progress from the SageMaker dashboard or CloudWatch. And then once training completes, you can deploy the model to a SageMaker endpoint. For each new document you want to analyze, you need to convert it to a word frequency vector using your vocabulary mapping, and then send it to the endpoint to receive topic distribution scores. So these topic distributions tell you how strongly each discovered theme appears in the document. And you use these scores for classification, search engine filtering, summarization, or clustering similar documents. And then you need to interpret your results. NTM outputs latent variables represented numerically and ranked by contribution. Each topic consists of top-weighted terms that frequently co-occur. Your job is to examine these term clusters and assign meaningful interpretations. Though unsupervised, you can provide a validation data set with labeled topics to calculate metrics like topic coherence or perplexity for quality assessment. All right. And we don't really need that one. Okay. And this is where you'd see some more about that. So how does this integrate with AWS? So as you've seen, it integrates naturally within the AWS ecosystem. S3 will store your input data, your vocabulary files, and model artifacts. SageMaker pipelines can automate your entire topic modeling workflow, and then Lambda or step functions can trigger post-processing or visualization workflows based on your topic modeling results. All right. And then for the exam, remember a couple of essential things. NTM is unsupervised and uses neural variational inference. It discovers latent topics in document collections. Preprocessing is mandatory. Tokenization, word to index mapping, and word count vectors are all included in that. Input formats are CSV or record IO protobuf via file or pipe mode. You choose the number of topics as a hyperparameter, if you've shown that. GPU instances are recommended for training and CPU for inference. So when exam questions involve grouping unstructured documents, analyzing unlabeled corpora, or discovering hidden themes in large text data sets, neural topic modeling is your answer. So thank you for joining. That will be all we'll have on NTM. Before we go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning exam. Have a good day.